Okay, here we are again, part 3 of the little guys. We're going to be talking about meteors, and we'll talk about the nemesis theory as well. So, basically meteors from meteor showers. In short, most of the time when we see them, especially the meteor storms, they're associated when the Earth passes through a debris of a comet. So if you recall what we talked about before in the preceding section on comets, that comets have a tail of gas and dust, and it is that dust that we see as far as the meteor showers are concerned. So each one of these meteor showers is associated with a comet, and they have, we've located those comets, and sometimes we know the density of the showers, or how many, sometimes we'll have more meteorites coming through than other times. It's easiest to find meteorites on the Earth if you look in particular places. You can, with current technology, you can follow them down and then locate large pieces. But preferentially you want to look for them in regions that are associated with resurfacing of the Earth occurring at a minimalist level. So deserts are a good spot, as indicated in these two pictures, as well as, if believe it or not, Antarctica is a good source. You could also find meteorites on Mars. So here is one guy there, a picture of it here. You can see regions on here that have been melted, and those are characteristics of meteorites in general when we pick them up. Griffith Observatory does have several of these objects there for you to take a look at. Sources of meteorites, comets, asteroids, objects that hit the Mars and the Moon. When those objects hit those two objects, the Moon and Mars, we're talking about the ejecta from the craters, and so we can then, some of those particles will go into an orbit, and maybe the Earth will capture them. On the other hand, if you had objects striking Mercury or Jupiter or even Venus, we wouldn't have materials coming from cratering ejecta from those places, because first of all, Jupiter doesn't have a surface to speak of, really, and then Mercury is so close to the Sun that one would find it hard to believe that any of that material would ever come back out to the Earth. And then lastly, Venus has so much atmosphere that nothing could get through it, if you will. The friction would be too great. So meteorites are the oldest objects that we have come across in the solar system. And we can do radioactive dating on those materials and come up with ages of 4.5 billion years for the solar system. So more information on these objects is from the Minor Planet Center, and they do have animations to show you, what they know about asteroids and little guys in the inner solar system, the middle solar system, and the outer solar system, and the near Earth orbiting environment. So let's see if we can get this one to play, which is kind of interesting. Notice the date down here, and the red objects are those that come by the Earth very closely, and the green and orange objects are things that are further away. So green is, very far away. So let's go back. So let's see over here. They discuss in detail, the meaning of these various things, and I'll leave that to your perusal. Okay, we'll go back and we'll now talk about the nemesis theory. And basically, the nemesis theory is an outgrowth of Alvarez's discussion and prediction of the crater in the Yucatan. And so that's this guy here. And people started playing games and looking at the mass extinctions and trying to understand them in terms of a periodicity associated with them. And so there are two articles here about them. And basically the idea of the nemesis theory is that you have a dwarf star, a red dwarf star, very small, just barely there, and it's orbiting the sun, and it's very, very far away from the sun. Sort of, if you will, something that's not observable. And the idea is that if we got too close to another star, then Nemesis would change its orbit. And the changing of the orbit would be such that every once, it's out here, spends most of its time out here, but then for a short period of time it comes and runs into the Oort cloud, and the gravitational interaction of Nemesis with these little particles here would cause some of these guys to fall into the inner solar system, and therefore some of them would hit us. All right, so that's the basic theory. But continued work since that time has shown that it's not a good theory. The basic reason why is that there is no red dwarf anywhere close to us. That's the primary one. Secondarily, if this article shows that the periodicity that is observed, in these charts here is a result of the binning. So it's an artifact of the data analysis. And you can take a look at that article here on archives.org with this particular date, and by Corrine Baylor-Jones. Okay, so let's take a look at this WISE data, which is this here. Basically, you can observe something with the brightness of Saturn out to about 5 parsecs away. No, I think it's 10 parsecs away. The inner orbit here is 5, and this guy is 10. So let's go back one. Now, as you can see from the legend, these are type of stars that are close by. We're here. The 9 indicates how many planets and objects we've got there, and P is planets. And the 2s running around here are these are binary stars, 4 quaternary star systems, things like that. So this is the WISE 2011 data. So this basically shows that there are no stars and red dwarfs that we can't see. So the nemesis theory falls because we don't have an object that's running into us. Okay, thank you very much.